I would like to make a recording. So let me check if there's a. Yes. Yeah, can you hear me? Okay, so today I'd like to talk about what is a confusion matrix. Yeah, it's an important measure for evaluation how the deep learning or machine learning methodology we develop is effective, about the accuracy, about the recall. So in the field, in the field of the machine learning, and specifically for the problem of statistical classification, typically, hold on. Yeah. Yeah, 在那个 Okay. So,博轩，博轩，帮我打开看一下。Yeah, so specifically the problem of statistical classification, it typically refers to the supervised learning. So it's known as a confusion matrix. It can be binary. It could contain more than 2 classes, or even the multiple classes known as the error matrix as well. And a specific table, the layout that allow the practitioners or data scientists to visualize the performance of algorithm. Yeah, thank you. Right. So it typically a supervised learning one. In unsupervised learning perspective, it is usually known as called a matching matrix. This is there's a no label, however, there's a ground truth knowledge to be understood behind, and then you would check the label, we call the pseudo label. Then you're going to check the correctness and the accuracy. So actually so the arrow row of the matrix represents the instance or actually class, while this ground truth label, while each column represent the instance of predict. So we can see that each row, this is the true, and the column representing the predicted. So actually we can check the correctness or incorrectness, and so vice versa. Both variants are found in the literature, so you can check the machine learning or the deep learning literature or textbooks. The name stems from the fact it makes it easy to see where the system is confusing 2 classes, commonly mislabeling one as another, like this a boy mistakenly considered a girl. So it is a special kind of contingency table, like doing the multivariate statistic with a 2-dimension actual and predicted, and identically sets of classes in both dimensions, and one combination of each combination of dimension classes variable in contingent table. So there's a several. Let me give example. Then given a sample of 12 individuals, we have 12 people in a group A that have been diagnosed with cancer. So cancer known as a positive, and if there is a cancer, and then and the other 4 are cancer free. If they are cancer free, they are negative. like we got the COVID. If you are infected, you known as a positive. If you are not infected, then you are considered as negative. Where individual with cancer belong to class 1, it is called a positive instance. And non-cancer individual belong to class 0. So this is a binary classification, is also known as a negative. So we can display the data as follows, like this. So actually, we have 12 people actually from the number 1 to number 8. They are positive. So out of the 12 people, we have A positive instances. Among the remaining 4 are negative. So assume we have a classifier that distinguishes between the individual with or without cancer somehow in any way. Then we can take the 12 individual and run through them, run through the classifier. So we have a predicted level, then classify, then make a 9. So like this, the actual. So this is predict classification. So from the 3, 1, 2, 3, 4, 5, 6. Yeah, only 6 we made the correct prediction. So then the classifier made how many? So 1, 2, 3. For the negative, the 4 out of 3 we made the correction about the negative instance. For the positive instance, totally we have 8. However, we only have a 1, 2, 3, 4, 5, 6. 6 out of 8. We made the correct prediction. So classifier then makes 9 accurate prediction and miss 3. So 2 individuals with cancer is mistakenly predicted as being cancer-free. So the sample 1 and sample 2 is right here. It's right here. So this is also known. This is called a type 2 error, also known as the consumer's risk. Consumer's risk. So in the machine learning literature, which is also known as a false negative. So in fact, it should be detected as a cancer. However, it is not revealed as a positive instance. So it's mistakenly predicted as negative. So we call it false negative. And for instance number 9, actual label is cancer-free. However, has been predicted. It should be cancer-free. However, we mistakenly predicted it is instance of cancer. So mistakenly claim it is the instance of the cancer. So we make a type 1 error. This case is also known as the false positive. In the literature of industrial engineering management, which is also known as the type 1 error or the false alarm. So there's a 1 person without cancer that is wrongly predicted to have cancer. This is sample number 9. This is known as the type 1 error. So notice. So if we compare the actual classification set to the predicted classification set, so there are 4 different outcomes that could result in any particular column. So like this. So the actual and the predicted. So this is with cancer and predict as a non. So for the false negative. There's a no cancer predict as it has a cancer. It has a cancer. The false positive. So it is it has a cancer predict as it has a cancer true positive. And this is a positive, and we can predict as a positive. So if it's negative and the predict is negative, is known as a true negative. So So we compare actual classification to the predicted. So there are 4 different outcomes. So this is 2 by 2 of 4 possible outcomes that could result in any particular column. One, if the actual classification positive and the predicted classification is positive, this is 1 and 1. So that is called the true positive result because the positive sample is correctly identified or correctly predicted by the classifier. Number 2, if the actual classification is positive, unfortunately, the predicted classification is correct, it's a negative. So this is a 1, 0. It should be detected as a positive. However, we are unable to review it. So this is called a false negative. This type 2 error. This is a really significant mistake we don't want to make actually in industrial engineering. So since it belongs to the consumer's risk, because the positive sample is incorrectly identified by the classifier as being negative. The third one, if the actual classification is negative and the predicted classification positive, so yeah, mistakenly to claim. So this is like we always calling the Wolf's Common. So this is called the false positive result because the negative sample is incorrectly identified by the classifier as being positive. So called the false positive. Typically, it's like a false alarm. Yeah, the like false alarm. So number 4, if the actual classification is negative and the predicted classification is negative, known as a 0 and 0. So this is called a true negative result because the negative sample gets a corrected gets correctly identified the classifier. So then based upon the result, the confusion matrix can be created. Then we perform the comparison between the actual and predicted classification results and add this information to the table, making correct result appear in green. So they are more easily identifiable like this. If it is a pink, this is a wrong prediction. If it is in green, then it indicates correct prediction. So the following template can transform into the table. For example, for any binary confusion matrix. So however, it is not necessary to be only with 2 classes. It could be 3 classes for 4 classes. So the template for any binary confusion uses a kind of result discussed as discussed above: the true positive, false, the negatives, the false negative, false positive, or true negative, along with the positive and the negative classification. The 4 outcome can be formulated into a 3 by 3. If it is a 3 classes, it forms a confusion matrix of size 3 by 3. For example, if the 4 classes, this is like a dog, cat, horse, or tiger. There's a 4 different classes. Confusion matrix going to be 4 by 4 of size 4 by 4. So this is the actual outlook of the prediction of the confusion matrix. So the actual row going to place in the horizontally in row. Predicted condition going to place vertically as a predictor label. So the true, the predict true, the true positive, and this is a positive. However, it's unable to identify it, the false negative, and so if it is actually it's a negative and the predicted positive, so this is a false positive. Is this truly negative and identify as a negative is a true negative? So look at this. On the diagonal, this is something related correctness we made. Off diagonal, are some instances we do not make the correct prediction. So the color convention for the 3 data tables above were picked to match this confusion matrix in order to easily differentiate the data. So now we can simply total up, so sum up each type of results, substitute into the template, and create a confusion matrix that will concisely summarize the result of testing the classifier, so known as assessment or evaluation of the classifier under investigation. So like this, based upon this example we got, so you have a 12. Actually, the actuality, we have 8 people with cancer, 4 people are cancer-free. Prediction, out of 8, we make a 6 prediction. However, among them, 2 are mistakenly identified with cancer-free. We have 4 cancer-free people in the group. Only 3 are correctly identified with cancer-free. Among them, one of them mistakenly identified as it has a cancer, however, he or she doesn't. So in this confusion matrix of the A sample with cancer, the system judged 2 were cancer-free. And this 4 sample without cancer. So actually the A, and it predicted 1 did have cancer. All corrected are located in the diagonal. So you can see that system judged 2 were cancer-free. So A, this is right here. And out of the, for example, without cancer, predict 1 has a cancer. So this is an arrow. So indicate by pink. And all the number marked in green are referring to the correct prediction. So it is easy to visualize visually inspect the table for prediction error only related to the pink, as the various outside the diagonal will represent them. And by summing up the 2 rows of the confusion matrix, one can deduce the total number of positive and negative. So positive P is a true positive, false negative. And the negative, this is a true negative, and the false positive, this is 4. So in predictive analytics, a table of confusion, sometimes also called a confusion matrix, is a table with 2 rows and 2 columns that reports the number of true positive, false negative, false positive, and true negative. So this always allows more detailed analysis than only simply observing the proportion of correct classification that is referred to as accuracy. So accuracy will produce misleading result if the data set is unbalanced. And that is when the number of observation in different classes vary greatly. However, sometimes it is taking place called the class imbalance. So based upon this, so prediction error. Okay, let me do this. Yeah, let me do this. So the first of all is known as a sensitivity, or called a recall. So, or the hit rate, or the recall, or true positive rate. So in the denominator, it is the P, the positive, all the instance of the actual positive. So in the numerator, put the P, P the true positive and true positive, false negative. And then this is totally true positive, a number of true positive, however, and how many the number of the instances that are true positive, that are positive. The numerator is referred to the true positive. This predict as a true positive. So that is also equal to the 1 minus the false negative array. So second, specificity, also known as selectivity or the true negative array. So in the denominator is n, the total number of the negative, the actual negative, and in the numerator is a true negative. So the n equal to the true negative or false positive. This is the number of the true negative, and the denominator in the numerator is a Tn, this true negative. That is also equal to the 1 minus FPR, the false positive array. And the precision will call the always the positive predictive value. So precision is a little bit different from the recall or specificity. So there's a called precision. The denominator true positive we predict as a positive, and the false positive. So this is how many the total number, the classified the number classified the instance as a positive. So which include the true positive and false positive. It could be predicted correctly and also can be predicted incorrectly. And in the numerator, only the portion of we make the correct prediction. This is the true positive. And PDR, FDR. Okay, this is a false. The predicted rate. Okay, the false. Okay, this will be addressed later. As I address FDR. And the native predicted rate. So FDR. The negative predicted rate. So this is totally so in the numerator, in the denominator is total negative plus false negative. So how many how many instances we predict as a negative, and the numerator only put the portion we predict the negative as correctly. So then remaining will be related to the above the measure. So this only this false positive rate or fall out. So totally the false positive. So how many instance we missed it, and totally this is totally n, the negative or the false positive, and then this is a false positive. Totally out of the number of the negative, and however sometimes we missed it. How many negative instance we missed it? So in the numerator put the false positive, and then the false discovery. So actually they almost the same. Okay, they are related. And the other called the PT ratio, the prevalence threshold. So this is take the square root FPR for the positive rate, and take the divide by the square root of the TPR and plus FPR. Okay, TS, the preference, and okay. Then we go to the accuracy. The accuracy, that means, so actually that refers to the number on the diagonal divided by total number, the P plus N. So this is the accuracy. Like here. prevalence, accuracy. The true positive, true negative divided by the older instance. And F1 score, it could be F1, could be F2, could be F.5. That is known as a harmonic mean or between the precision and the recall. So you like to balance to make a balanced score between the precision and sensitivity. So this is a 2. Yeah, this is called the harmonic means 2 by 2 by the precision, so true positive rate. So F score. So this is a PPV. Hold up, PPV. The recall. Recall. PPV. This is a precision. PPV is a precision, and times the true positive rate. The precision times the sensitivity, precision time the sensitivity or the recall divided by the precision plus sensitivity or recall and the times by 2. Okay. So the only F score this is a widely used measure. So okay, so there's something else, some more information you would like to look into that. More than category, like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a perceived and this is a vowel produced. So there's more than 2 classes. So there's a whistle language between 2 speakers, zero value omitted for. Okay, so for a vowel produce the perceived vowels. So this is actual. This is predict. So only 1 out of 16 has been predicted incorrectly. The well, this is only 1. The A, there's 84 out of 84, there's 79 out of 84 predict correctly. This 22 out. This is 15 out of 22 predicted correctly. This is the 2 out of 4. So this is more than classes. Okay, so I stop here. So please refer to this confusion matrix for personal reading at home. So in class, I will give some examples. So I will ask some of you try to explain the confusion matrix for us. Then we have a further discussion. And also, please be sure when next time you like to present your next computing homework or programming homework by using the CNN. So confusion matrix will be the one for your evaluation of your proposal. You might use the CNN. You might use a VGG16 model. You can use a residual net. You can use a transformer, or you can use using the ResNet or something, or efficient net or so, and so on. So okay, so this is the video clip about describing how confusion matrix works for your evaluation about your proposal, particularly in the supervised learning.